Okay, let's dive in. You probably had some caffeine today, right? I mean, maybe coffee, tea.
Or even, some chocolate or a soft drink. It's in so many things.
Exactly. Caffeine is just everywhere. One of the most consumed things, really, on the planet. We all know it makes you feel more awake, less tired during the day.
Uh-huh.
But what if it's doing something, well, surprising, maybe even significant, while you're actually trying to sleep?
Yeah, that's precisely what this new research is digging into. It's looking way beyond just, caffeine blocking fatigue or keeping you from nodding off.
Right.
This study looks at how it physically changes the brain's activity during sleep itself,
Huh.
and critically, how that might be messing with the overnight recovery process.
That recovery we need for, well, physical restoration, but also keeping our mind sharp.
Exactly. Both aspects.
So this isn't just about, can I fall asleep after that espresso? It's deeper. It's about these subtle shifts happening in the brain's basic activity patterns while you're asleep, but with caffeine still in your system.
Mm-hmm. And the really fascinating details we're exploring today, they come from new work out of the University of Montreal.
Okay.
It was led by Philip Tholk, Karim Jerbi, he's at UDEM and Millet, and also Julie Carrier from UDEM's Center for Advanced Research in Sleep Medicine.
And this was published where?
In communications biology. Pretty high profile.
Okay. So our mission for this deep dive is what? To sort of walk everyone through this study?
Yeah, guide you through it and really highlight the key findings, which might be, well, quite surprising for many people, about this interaction between caffeine and your brain at night that we don't often think about.
Right. So how did they actually do it? How do you peek inside a sleeping brain that's, had caffeine?
Well, they worked with 40 healthy adults, and they used electroencephalography, EEG.
EEG. Okay. That's the cap with the sensors that reads brain waves.
That's the one. It records those tiny electrical signals, giving you a picture of brain activity all night long.
Yeah.
But here's the clever part. To see the subtle caffeine effects, they didn't just look at the raw data.
They needed more.
Yeah. They combined it with AI, artificial intelligence, and some pretty advanced statistical analysis. These tools can spot complex patterns that, the human eye might just miss.
And the setup for the participants, how did they compare caffeine versus no caffeine?
It was a neat design. Each person slept in the lab on 2 different nights. On one night, they got caffeine capsules some 3 hours before bed, then another dose 1 hour before.
Okay.
And on the other night, same timing, but they got a placebo, a dummy pill.
Ah, so that direct comparison lets you isolate caffeine's effect specifically during sleep. Smart.
Exactly. It controls for other variables. And what they found, well, it's quite eye-opening.
Okay, hit me with it. What's the core discovery?
The main thing is that caffeine increases the complexity of the brain's signals during sleep. And, maybe even more intriguingly, it enhances something they call brain criticality.
Criticality. That sounds active, almost counterintuitive for sleep, doesn't it? What does that actually mean for a brain supposed to be resting?
It does sound a bit odd for sleep. But the researchers used a helpful analogy. Think of an orchestra.
Okay.
If it's too quiet, just silence, nothing's happening, right? No music. But if everyone just plays loudly whatever they want, it's pure chaos, just noise.
So criticality is that perfect balance, the sweet spot between total order and total chaos.
Exactly that. Jerbi is quoted explaining it as a state where brain activity is both organized and flexible. Now, when you're awake, this critical state is actually optimal.
Right. That makes sense for being alert, learning, reacting.
Yeah, it lets your brain process things efficiently, adapt quickly, learn, make agile decisions, all good things when you're awake.
Okay, but the kicker is this research says caffeine pushes the sleeping brain towards this optimal for wakefulness state.
That's the really significant implication, according to Carrier. Caffeine essentially nudges the sleeping brain towards a state that's, in her words, more awake, alert, and reactive.
Which sounds great for daytime.
But potentially disruptive at night. She suggests it could interfere with rest at night, because if the brain is stuck in this more critical, more ready-to-go mode, it might struggle to neither relax nor recover properly.
Wow. So it's not just finding it harder to drift off. The sleep you do manage to get might be fundamentally less effective because the brain's actual operating state is wrong for the job of deep rest.
Precisely. The data points to caffeine, actively changing the kind of processing the brain is doing while you're unconscious. And they saw clear evidence of this in specific brainwave changes.
Brainwaves, those are the different rhythms, like alpha, beta, theta. What did caffeine do to those rhythms during sleep?
They found caffeine attenuated, basically. It reduced or weakened the slower oscillations.
The slow ones. Like theta and alpha waves. Aren't those the ones linked to deep restorative sleep?
Exactly. Those lazy rolling rhythms got quieter, essentially.
Okay, so less of the deep sleep waves. What about the faster ones? The ones more associated with being awake and thinking?
Well, they saw an increase in beta wave activity. Beta waves are much more common when you're awake, mentally engaged, maybe even a bit stressed or anxious.
So the brain's electrical signature literally looks more awake even when the person is asleep.
That's a good way to put it. As Jerbi summarized, these changes suggest that even during sleep, the brain remains in a more activated, less restorative state under the influence of caffeine. The whole pattern shifts.
That's pretty profound. The brain's operating system is shifted. How might that impact what the brain is actually supposed to be doing overnight, like memory?
Well, the researchers think this shift in rhythm may help explain why caffeine affects the efficiency with which the brain recovers during the night. And memory processing is a huge part of that overnight job.
Right.
They specifically noted this increased complexity, this altered rhythm, was particularly obvious during non-rapid eye movement sleep and REM sleep.
And REM, that's the phase before you get into the really vivid dreaming, the deeper stages.
Exactly. NREM includes those crucial deep sleep stages, vital for things like memory consolidation, sorting and storing the day's information, and just general cognitive recovery.
So caffeine is messing with brain activity right when the critical overnight maintenance and filing should be happening.
That seems to be the implication. It's changing the brain state during that crucial window.
Okay, wow. So caffeine isn't just an on-off switch for wakefulness. It's actually changing the character of the off state. But hang on, there was another layer to this, right? It wasn't the same effect for everyone?
No, and this was another really striking finding. These effects, the increased complexity, the enhanced criticality during sleep, were significantly more pronounced in young adults.
Young adults, meaning?
In this study, specifically those aged 20 to 27, their brains reacted more strongly compared to the middle-aged participants who were 41 to 58.
So younger brains were pushed harder towards that awake-like state during sleep by the caffeine.
Precisely. And the difference was especially noticeable during REM sleep, the dreaming stage in the young adults. Caffeine seemed to have a bigger impact on their brain dynamics during REM compared to the older group.
Huh. Why would age make such a difference? What's the biology behind that?
The researchers propose it relates to something called adenosine receptors.
Adenosine.
Yeah.
That's the chemical that builds up and makes you feel tired, right? The sleep pressure signal.
Exactly. It accumulates throughout the day, signaling that your brain needs rest.
And caffeine's main trick is blocking those receptors, like putting little caps on them so the adenosine can't deliver its sleepy message.
That's the classic mechanism. Caffeine is an adenosine receptor antagonist, or blocker. It stops adenosine from binding, which is why you feel alert even when adenosine levels are high.
Okay. So how does age fit in?
Well, the source quotes Carrier explaining that the number of these adenosine receptors naturally decrease with age.
Ah, so older brains literally have fewer docking stations for the caffeine molecules to latch onto.
That seems to be the leading hypothesis. Fewer receptors mean caffeine has less opportunity to block them, and therefore less power to influence brain complexity and push it towards that awake-like state during sleep.
Which would explain the reduced effect they saw in the middle-aged group.
Right. So the conclusion drawn in the source is that these age differences suggest younger brains may be more susceptible to the stimulant effects of caffeine, and that susceptibility extends to these less desirable effects on sleep architecture and quality.
So if you're in your 20s, that late afternoon latte might be altering your sleep state much more dramatically than for someone in their 50s. That's quite something, especially considering how much caffeine younger people tend to consume.
It really does underscore why understanding these complex age-dependent effects is so important, given that caffeine is, a daily tool for managing fatigue for millions across all age groups.
Absolutely. And the researchers themselves stressed that point, didn't they? That more research is needed.
Yes. While this study provides really crucial insights into the what and the how caffeine affects the sleeping brain's dynamics, they emphasize that more work is needed to fully understand how these neural changes translate into, say, long-term impacts on daily cognitive health, mood, and overall functioning.
Makes sense. But this kind of research, it does open up possibilities for the future, maybe.
It certainly could. Understanding these kinds of dynamic age-related effects might eventually help guide more personalized recommendations for caffeine intake.
Tailored advice based on your age and maybe even your individual sensitivity. That would be interesting.
Potentially, yes.
Okay, so let's try and pull this all together. This research really takes us beneath the surface of caffeine, doesn't it? It shows it's way more than just something keeping you awake.
hmm It actively changes the fundamental structure, the rhythm of your brain activity while you are sleeping, pushing it towards a state that's more active, more complex, but ultimately less restorative.
And crucially, the strength of that effect isn't the same for everyone. It seems to hit younger adults significantly harder.
Likely linked to those changes in adenosine receptors as we age.
Which, given how caffeine is woven into our daily routines, understanding these nuances feels really important, just as the researchers said.
And maybe, just maybe, this work paves the way for smarter, more personalized guidance on using caffeine down the road.
It definitely adds a fascinating, maybe slightly worrying layer to thinking about that daily cup.
It certainly does. Makes you reconsider that 4 p.m. coffee, perhaps.
Absolutely. So here's something for you, the listener, to mull over. Now that you know this, that caffeine is likely changing your brain's criticality and rhythms during sleep, nudging it towards a less restful state, especially if you're younger, how might that influence how you think about your own caffeine habits?
Yeah, what could the subtle, unseen effects be on your overnight recovery, on how sharp you feel the next day, especially considering your own age bracket?
Something to think about next time you reach for that coffee.
That
Or that tea, or yeah, even that piece of dark chocolate late in the day.